Today I am making another video on NMR and how to calculate the concentration of a certain compound in terms of internal standard. So before going to real example, I try to make some presentation here. Just let's see how we are going to do this calculation. So here the example, internal standard is DMA, dimethylacetamide. So specifically this, just see this methyl group, it has a 3 hydrogen, and this is used as an internal standard. So based on that you can calculate the other peak concentration. So let's check. This methyl peak is this, so I did the integration. It is for 3 proton, remember it is for 3 proton. And then this is, suppose this is another compound present in the reaction or like in the crude or somewhere, and it is for 3 proton, and this is peak is for 2 protons. So we did the integration for A 2 proton, B 2 proton, and C 2 proton. So as I mentioned, DMA as an internal standard, and suppose the concentration of DMA is 25 millimolar. So now if we want to see the concentration of this compound or this compound, how we can calculate the concentration. So first of all, integrate the DMA peak first and then edit that DMA peak as integral value as 25 millimolar, since we take this concentration as a 25 millimolar. So it is the methyl peak for 3 proton, so this one. Then integrate other peaks in terms of DMA, because you already integrated this peak and edited the integral value as a 25. So based on that, relatively other peak also will be like close or higher or like lower. So if you see the example, I will show you definitely, then you will understand what I'm talking about. So suppose after making this as a 25, suppose you integrated this and you get the value as a P for this proton D type proton. Maybe this is another compound, and then this D type proton also for the 3 proton, this peak is for 3 proton, then your concentration of the compound D will be amount P, that means this P, like this integral value P over the number of proton for D type. So that's D type compound number of proton also 3, and times number of proton for internal standard. So number of proton internal standard is 3, so that 3, and total value will be in unit, it will be millimolar. So in short, P over 3 times 3 millimolar. So this is easy for, because your internal standard has a 3 proton, that is specific peak, and your another compound has a 3 proton for that specific peak, so the concentration will be easy. But how about these peaks? Those are like for 2 protons. So let's see another example. So now if we want to see compound A, so concentration of compound A will be P. P means like this area, sorry, integration area or integration value of, suppose you get P. So P over number of proton for A type, here number of proton for A type is 2 times number of proton for IS internal standard, that is 3. So 3, and unit will be millimolar. So let's see an example. So here if you see, this is called EDC, or 1-ethyl 3-dimethyl aminopropyl carbonamide. So it is in short called EDC, and after the reaction it is converted to urea. So if you see this methyl peak and this methyl peak, so in the reaction we can monitor with in terms of this methyl peak and methyl peak. So let's see a reaction. So here there is a dicarboxylic acid, and EDC, if you add EDC in a system like aqueous medium or something, So it will form two anhydride bond to make this macrocycle, and ultimately EDC will convert to urea. And there is a very interesting chemistry. If you are more interested to know what is this and what is the research behind this, so I have published one of my research work on this based on these reactions. So this is a paper, so dissipative assembly of macrocycle comprising multiple transient bonds, and I was the first author of this paper. So it is a very interesting paper. So if you are interested to see this dissipative assembly or like dissipative chemistry, this is a new term in the chemistry research. So you can give a look on that, and so you'll get idea how EDC coupling reaction happen here, and this reaction actually happen out of equilibrium system. So all the organic reaction normally goes or like happen um, in or at equilibrium condition, but this specific type reaction is called out of equilibrium system. So let's see the example of calculation or of the concentration of the compound from the NMR. So that specific reaction, what I just showed in my previous presentation, that reaction is here. So first of all, let's make a zoom in this area, and this peak like 2.08, this is actually the DMA, that methyl peak, so 3 proton methyl peak. So let's do the integration of this peak first. It is the internal standard, remember that. So make this integral, so it is showing 1. So now make this 1, edit integral, put here, because I took this DMA as a 25 millimolar concentration, so I will add 25 for this peak, and then I will calculate this peak like this triplet, and also this triplet. So this is the EDC, what I was talking about. This is the EDC, and this is the urea after the reaction EDC converting to urea. So see, this was 25 millimolar, and the EDC also used 25 millimolar, but it is in the reaction, so EDC will be always decreasing and urea will be increasing. And since this peak for the DMA, this peak, this is for 3 proton and it is showing 25, and this EDC, this is also for 3 proton methyl, so it is showing 12. So originally EDC was added in this reaction as a 25 millimolar. So after reaction, now we can say it is not exact amount, remember that, it will be like close value. So it is staying as a 12 millimolar still in the reaction, and some amount of the urea formed, that is like around 7 millimolar urea formed. Now, so this is the one type of like reaction monitoring system. So let's do in the aromatic region. So if I zoom that area, so I know all those 3 peaks are, each of them are like for 2 proton, and all 3 are from the same compound. But if you see, these protons have something already in the reaction forming, so it will be tough to integrate and like to get a good estimation. But mostly this peak is like kind of clean or like better than those two, so you can now integrate that part, this peak, then we can get the concentration of that acid. This is dicarboxylic acid you saw in the so this is the dicarboxylic acid, this is specifically. So now we see here it is showing 10.25. So that doesn't mean that this acid concentration is 10.25. Remember that this is for 2 proton and internal standard is 3. So now if you want to calculate what is the concentration of this, so you get this p value as 10.05, maybe, yeah, 10.05, and it should be divided by 2 because this is for 2 protons. So you will get 5.025 times internally standard has that integral value for 3 protons, so times 3, so you will get 15.075. So originally I took this acid as a 25 millimolar, but after some reaction it is staying as a 15 millimolar concentration. So this is like within 5 to 10 second reaction I'm uh, discussing. Like, let's see after 1 or 2 minutes later how this reaction is reaction condition. So um, so zoom it again and see that internal standard peak is 2.08. Now if we do the integration, so this peak again for 1, now we will edit this peak as 25, and then based on that we will do the integration of other peak. So let's see here, 10, let's zoom it first, then it will be easy to understand. So now do the integration of this peak. This is converting urea. So if you see, now the EDC remain 10 because it is 3 proton, and your DMA like internal standard also that is for 3 protons, so it will be like 3. So whatever the P value you will get, that is the value of the concentration. So it is 10 millimolar and urea is forming 8 millimolar. So if you see just initial of this reaction, even it was decreasing, but it is decreasing slowly. The EDC is decreasing slowly, converting the product. So it was 12 millimolar and 7 millimolar, but in the second, like after 10 to 15 scan, maybe within 5 minutes or something, so it stays 10 millimolar and urea forming 8 millimolar. Now let's see our acid concentration like dicarboxylic acid. So if we do this peak integration again, although it has something around it, but still we can get some close value. So now it is showing 7 millimolar, but previous one, if you remember, it was showing like 10. Oh, actually not 7 millimolar, so 10, and we got 15 because whatever the value we are getting here, because these are 2 proton, so then it was more like 10 and it was like 7. So if we get 7, so you can say 7.24 divided by 2 because it is for 2 proton times 3 because 3 was for the original internally standard. So it is like 10.86. So in the first one the acid was 15 millimolar, but it is now 10.86 millimolar. So now let's see another same reaction, another time point. It is like maybe after 10 minutes, and if we make zoom and do that area like integration for the internal standard, so internal standard is 1, so edit it for 25, enter, and then do the integration for those EDC and urea. So EDC consumed, and the concentration of the EDC originally was 25 millimolar, but it is now 5 millimolar, and urea is like 13.86 millimolar. Monitoring how much pure EDC is there and how much final product urea is forming here, and also in the acid region how much acid is there. So now if we integrate that part, so you can see like now it is 5.52. So if we calculate how much acid we have, so 5.52 divided by 2, because this peak is for 2 proton, 2.76 times internal standard is 3 proton times 3, so you are getting 8.28. So after 10 minutes still your acid has 8.28 millimolar. So this is how you can calculate the concentration of a certain product if you know the which peak is for which product. And if you use an internal standard, so you only need to know the number of proton for your internal standard, and then you can find out the concentration according to this equation. So here again now you will understand. So this peak is for 2 protons, C proton is 2, C peak is for 2 proton, and if you integrate this internal standard as a 25, then if you integrate this peak and you get like a p value, like p value means whatever the value it is, so you will take that value and divide that value with the number of proton for that peak. So 2 proton times number of original internally standard proton, like which is like for 3. So then you can get the concentration of the compound, your interested compound. So similarly for the EDC and urea, whatever you have seen in the original NMR. So again, if you are really interested to see more about this kind of chemistry and like the dissipative chemistry, macrocycle formation, so you can definitely go through this paper. You can learn more about it, and if you have any question, you can ask me. So thank you for watching my video, and please share my video, and if you're not subscriber, please subscribe my channel. It will help me to make more video. And I am really thankful to the people who already subscribed me and watch my regular video and ask me question, and I also try my best to answer those questions. Thank you again. Till my next video, just stay safe and fine, and goodbye.